Hey everyone, every time we ask an AI to look at an image, there's this incredibly complex and pretty expensive process that kicks off behind the scenes. Today, we're going to pull back the curtain on that process, because once you understand it, you understand the real cost of AI.
So let's start with the big question. What does it actually cost for an AI to just look at a single photo? Well, the answer isn't measured in pixels or megabytes. It's measured in a currency you've probably heard a lot about lately, tokens. And figuring out how a picture becomes a token, that's the key to the entire economics of AI vision.
To get this, we kind of have to look back a little. The old school AIs, these things called convolutional neural networks or CNNs, they saw images the way we do, as a grid of pixels. But modern AIs, the transformers that power giants like GPT-4, they don't think in grids. They think in sequences, just like words in a sentence. So, to get these incredibly powerful new models to understand images, engineers had to teach them how to read a picture, not just see it.
And that creates what you could call the pixel-to-token problem. You just can't feed a grid with a million pixels into a model that's built to read a line of text. It's a total mismatch, like trying to play a video on a record player. So before the AI can even begin to understand what's in the image itself has to be translated. This roadblock led researchers to a really profound question. What if we could make an image work the same way as a paragraph of text? That single idea completely changed the game. It opened the door to what we now call multimodal AI. These incredible models that can understand images, text, and sound all at once.
And the upsides to this unified approach are just massive. It means you can use the same fundamental technology, the same architecture, to understand both a Shakespeare sonnet and a photo of a cat. This makes training so much more scalable, and it unlocks what's called cross-modal reasoning, the AI's ability to truly connect what it sees with what it reads.
Okay, so how does this translation actually happen? How do you take a picture and rebuild it as a sequence of tokens? Well, it's a fascinating three-step process, and this is really the heart of how modern AI sees the world. Here they are, the three crucial stages. First, the image gets broken up into smaller pieces. Then, those pieces are translated into the AI's native language. And finally, the whole thing gets compressed to make it way more efficient. Let's break them down one by one. Step one is called patch extraction. So instead of trying to analyze millions of individual pixels all at once, the AI basically takes a pair of digital scissors and carves the image into a neat grid of smaller squares. We call these patches. It's a lot like cutting a photo into jigsaw puzzle pieces before you try to figure out what it is. And this is where the math starts to get, well, a little wild. Take a look at this. A pretty standard 1024 by 1024 pixel image, if you break it into 14 by 14 pixel patches, instantly becomes over 5,000 individual pieces. Every single one of those is about to become a token. You can already see how the cost is going to start adding up, right? Next up is linear projection. This is the magic moment, the actual translation. Each one of those little pixel patches gets converted into a long list of numbers. Then, that list gets transformed into a special mathematical code. We call it a vector. You can think of this vector as a super rich, dense description that captures all the color, texture, and shape information from that tiny patch. This vector is the token. This is what the AI can finally understand. But, processing thousands of tokens for every single image is still incredibly slow and expensive. So there's one final, really critical step: spatial compression. Before the AI does all the heavy analytical work, it uses some very clever techniques to summarize the visual data, basically trimming down the total number of tokens without losing the most important details. Now, the exact methods they use for this compression are often proprietary secrets. That kind of efficiency is a huge competitive advantage. But the effect is massive. Models can often achieve a 2x to 4x compression. That means they might only need to actually process a quarter of the original tokens. It's this efficiency trick that makes large-scale image analysis financially possible at all. All right, so we've covered the how. Now let's talk about the how much. It's time to connect all these mechanics to the bottom line. Because this isn't just theory. This is literally the math that determines your AI bill every month.
This is the basic formula for figuring out the raw number of tokens in an image. You just divide the image's width and height by the patch size and multiply them. But what this formula really tells you is something very simple. A bigger image or a smaller patch size means way more tokens, and that means higher costs, period.
And this chart, wow, this really puts it all into perspective. Look at this. A decent-sized text prompt, a few hundred tokens. A single standard image, over 5,000. And a short 10-second video clip,
That can be tens of thousands of tokens. The cost of vision is just in a completely different league than text.
Let me put this another way, because these numbers are just staggering. Asking an AI to process one 4K image is like asking it to read 15,000 words. And analyzing 1 minute of video, that's the token equivalent of handing it a 112,000-word novel. Suddenly, those crazy high API bills for vision tasks start to make a whole lot more sense, don't they? So the big question is, what can you actually do about this? The good news is that understanding this process isn't just academic, it actually gives you control. So let's go through a few key strategies to really master your AI vision budget.
There are 3 huge levers you can pull. First, resolution. Just resizing a large image before you send it to the AI can literally quarter your token count. It's that simple. Second, frame rate for video. You almost never need to process all 30 frames per second. Sampling just 1 or 2 is massively cheaper and usually just as effective. And finally, caching. If you're going to use the same image over and over, save the tokenized version. That way, you only have to pay that expensive conversion cost one time.
And really, this brings us to the most crucial point of this whole explainer. The journey from a pixel to a token isn't some abstract computer science concept. It is the cost architecture of modern AI vision. For anyone building with this tech, understanding this math is no longer optional, it's essential.
So I'll just leave you with this final thought to chew on. Your AI sees the world in tokens. Are you still budgeting in pixels? Thanks for tuning in.